Okay, so hello everyone, and welcome to this new live coding series where we learn about how to write reasonable React applications. Before we start, just let me check the stream a little bit. Okay, so welcome guys, and welcome to this new live coding series called Learn Reasonable React Applications. Before we start, I would like to take the opportunity to thank 𝗘𝗵𝗃 for providing me with this chance to share my knowledge with you guys. And I want to thank you guys for coming in and checking this live coding series. So with that being said, let's dive right in. So, reason. And what does it mean to write reasonable React applications? Well, actually, it really just means that we are going to use the ReasonML programming language, and we will see how we can leverage the power of this language to write safer and enterprise-grade React applications. As you can see here, before we start, I would just like to tell you what we are going to do in this episode. So we are going to talk about a little bit about ReasonML. Then we are going to set up our development environment, and then by the end we will write our first Reason React component, and we are going to show it on the screen. And then we should hopefully have some time left for a Q&A session where you ask me anything you want regarding what we saw, or any other question that's in regard to this subject. So ReasonML. So as you can see here, this is the official documentation for ReasonML. And it says that Reason lets you write simple, fast, and quality type-safe code while leveraging both JavaScript and OCaml ecosystems. And just to, I'm sorry. And what I think what we really want to take off from, or the thing that we need from Reason is that, or we need to know about ReasonML, is that it was created at Facebook, and it was created actually by the same guy who created ReactJs. And just for your information, guys, I'm sorry. For your information, guys, ReactJs actually, in its first iteration, it was not written in JavaScript, but it was actually written in standard ML, which is a functional language, and it was then ported to OCaml, and then ported to JavaScript for wide usage. It was not really a technical decision, more than it was just so that more people can get on board with the ReactJs framework. But now that the framework React has taken off, actually Reason brings React closer to its root, and we will see how, you know, so many times people say that writing ReactJs is just like writing JavaScript. It's even way more true for ReasonML than just JavaScript. So Reason is this programming language. It's a functional programming language, and it has many of the things that React wants. It has it out of the box, like things like immutability, things like function composition and many of the idioms you think about or that you want to use in your React applications. They come actually baked in ReasonML. So we said that ReasonML is this functional language. Is actually a typed functional language. So it has types all over the place, but the catch is you do not need to write the types. So we have types everywhere, and the compiler checks for everything, but you do not really need to manually write that many types by your hand. And this is one of the big differences from ReasonML and other statically typed languages that you might know. So if you're coming, let's say, from a Java background or from a TypeScript background where you use to write so many of the types manually, this is going to be really different, and we will see why and how. So to get started, I actually set up a repo where you guys can just clone the repo and you can start coding with me. So you can find the so you guys can find the repo here. I will put it in the comments, and it will also be in the comment section for the people who will be watching this on YouTube later on. So I will share with you guys the link to the repo, so you can just download this the repo and start coding with me. So just to get a to know what application are we going to build to actually learn all the concepts that Reason brings and how to use Reason with React, we will be actually writing an application, this kind of to-do list. It will have routing here, so you can see that this is the about page, this is the home page, and we will be able to edit our to-dos. We will be able to change their completed state, and also the to-dos, we will be fetching them, so we will be communicating with an API to get the data we want. So just so that we do not waste time and spend most of our time I'm sorry. So just so that we do not spend most of our time just waiting for the repo to get cloned and then build the application, I already downloaded the repo and I already compiled everything, and just so that we do not waste time. So before we start coding, I think we will see how we can set up our code editor. And I believe most of you guys use Visual Studio Code, so we are going to see how we can set up our Visual Studio Code to start programming in ReasonML. So with that said, we will head right to our Visual Studio Code and hit enter. Here's our Visual Studio Code. So what you want to do is go to the extensions and then look for the reason. You want to look for the reason keyword, and it should be actually the first extension to pop up, which is Reason VS Code. You will have to install it and you will be done. And as you can see here, we have syntax highlighting. We have here, it shows the dependencies. We have here hover information, so it says that this make is the type unit to React element. So when you do this, you're mostly done, and you can start writing reason code in Visual Studio Code. But personally, I'm not someone who uses Visual Studio Code, so I will be just using the terminal with Vim. I'm a Vim user, so this is what I am going to be using for this series. So let's just to see what we get out of the box from the repo. So I'm just going to run these commands. Yarn rewatch. I was the Yarn package manager. You can use npm. If you're used to using npm, it will be mostly the same thing. So I use this command to actually compile my code and compile the reason code into JavaScript code that the browser can understand. And then I'm going to start my development server using the command yarn dev. And you see here our dev server started so fast. And we can go here to the local host 3000, and as you can see, it's a blank page that says a hello world here at the top left corner. Make the font bigger. Okay, so I guess we can do this. Okay. So let's now see what we have in our index.html, which is the file being served to the browser. I don't know if the font is big enough for you guys. Do I need to make it more big? Okay, I will make it a little bit bigger anyway, so we can. I believe that's good enough. Okay, so as you can see here, this is your usual index HTML when you are writing a React JavaScript. It really has just this empty div tag with the ID of root. It can be anything you really want it to be. And you have this script that loads your JavaScript. You might notice here that I am using this type module. And this is because for the development server, the tool I am using, it's called Vite, and it relies or it uses ES modules to load our assets to the browser. And in here, you can see that the source file is called index.bs.js, and that's the name of our index file, but it's compiled to JavaScript. So our reason files, they end with the .re extension, as you can see here. So if you go to the srcs, so you can see here that our reason file, they end with the .re extension, but the compiled version, it's actually .bs.js, and that's what gets served to the browser. And we can head here to our index.re file, and what you can see here is that I am importing the CSS file that we are going to use for this live coding series. And all we really do is just this one-liner that mounts the app component to the root element in our HTML. So the first thing to notice is that we do not actually import our modules. We did not import this React DOM module. We also did not import this app component, and we did not import anything. And that might seem weird, or like you might be wondering, how is this working? I'm sorry, it's actually because the compiler knows about all of our modules, and all we need to do to use our modules is just reference them by name, and the compiler can figure out where each module lives, and it can bring all of the informations or the functions or the values we use from that module. So the compiler takes care of all of that for us. And what that really means, I'm sorry. What that really means is that you can have any folder structure you want. So you can have a first folder structure, and maybe you're not that much happy with it. You can change it, and you will not need to touch your source code at all. Like, you can have any folder structure you want, and the source code will just stay the same. You will not need to maintain any import statements or anything like that. So here we have this app component, and it should be living in this app file. So we go to this app.re file, and as you can see here, this is just a function that takes no argument and returns the JSX. So one important thing to know about ReasonML is that JSX is part of the language. So we do not need anything outside of our compiler to actually write and use JSX. So we do not need things like Babel. And this is one of the properties I'd like to say about ReasonML, is that really we do not need that many dependencies for our codes to write. And as you will see, we will not use, let's say, the React router. We will not need Redux. We will not need many of the libraries you usually use in your React applications. So most of the things, they just come out of the box with the language. So I think that's one of the benefits of using ReasonML to write React applications. So do you remember when I said that Reason is this functional, statically typed language? And as you can see here, this is really not that much different from JavaScript. So I did not really write any type annotations. I did not write any types, but the application compiles and I'm sorry. So the application compiles and it works just fine. And as you can see here, when I hover over this function, as you can see, it says that it takes a unit. So unit is like void if you're coming from Java or TypeScript. So it's a function that takes nothing, and it returns a React element. So it knows that this is actually JSX, and the output of a JSX is a React.element. We did not need to write any of the types for this to work, and we will see how this will be like even more apparent where we start using some of the types. For example, the type of a to-do. What is a to-do? So we will write the type of the to-do. We will do it once, and we will not really need to use types much more than that. So one thing that you might be wondering about, which is this this annotation, this @react.component annotation. And what this does, what this says is actually it just tells the compiler that this function is actually a React component, so that it translates it to appropriate React calls for the browser to display it. So let's make, I think another thing that we want to talk about is this React.string, right? So you do not see this in JavaScript because you usually just write your strings as they are, and they just work. But in ReasonML, as I have told you already, everything has a type. So you cannot have JSX and have strings inside of it. So JSX is just a React element. So JSX, it actually means a React element, and you cannot have strings inside of elements. What you can have actually is another element which can be inside of your JSX. And all this function does is that it takes our string and it returns it into a React element. And you might be wondering, why do we have this function? Actually, this is really beneficial. Why is that? Because many times the things that you want to display on the browsers, they are not really handwritten, but they come from other sources. So sometimes, let's say they come from a database or from an API that you call, and instead of really writing this handwritten or hard-coded string, you usually will do something like this. So you do let hello, and let's suppose it comes from some API, and it's supposed to be hello world, right? Oh, okay. So we can here change what we have inside of this string and tell it to just display our hello variable. And so we have, okay. So here, okay. So we just forgot about the semicolon here. Semicolons are important to Reason, and we will see later on why. So let's say, for example, in here, what I got from the API is not a string, but actually I got, let's say, an integer, right? So sometimes you're expecting a string, but you get an integer, and the compiler will actually know that it's false, so that it's the wrong argument. You wanted a string, but you got an integer. So the compiler tells you, hey, you have a problem here. I was expecting a string, but I got an integer. So we need to use the right words or the right types for our components. So if we see here, we're going to see that the application is still compiling. So at first it failed because we had some problems, but now it compiles, and if we go back, we see that it's still working. So what we want to do right now is write our own component. So to write our component, we need to write it inside of a module. So in Reason and Reason React, every component is a module. So we have to put it inside a module like this. So let's say, for example, I have this to do, or let's just say let's call it to do, and then just like we did here with this make function, we just write a React dot component, call our function make. Then let's say it takes nothing, and it returns a div that has a string inside of it that says this is a to-do. So now that we created this module, which contains our component, we can actually just use it here. So this is the syntax for React fragments that you might be familiar with. And below our hello component, let's use our to-do component. So we write this, and as you can see, it was formatted for us. So one of the things also about Reason is that we do not need things like period, because it also comes out of the box with Reason ML. So you will see that all Reason ML code bases, they all follow the same formatting throughout the whole word, because it actually comes with the compiler, and there are no that many options to use for your formatting. So everyone writes the code in the same way, so it makes it really more readable for everyone in the community. So let's see the result of our JSX here. And as you can see here, it says this is a to-do, and that was our first Reason React component. So yay us. And so we have here 4 minutes left. So I will let you guys ask any questions that you might have, and I will answer you to the best of my ability. So don't hesitate, guys, to ask your questions on the stream. So if you guys do not have questions, I will be, I guess we will add some CSS, just some CSS to make this look a little bit better. So let's say, for example, let's turn this into a div. And as you can see here, it's telling us about the error. So we need a div here. And let's add, for example, a class name. So this is, I believe, nothing new. So let's say, for example, change the padding to be, add some padding, and change the background for, let's say, some blue background. And let's say, for example, change the text to be white. So as you can see here, this is how the class names work, and it's really close to what you're used to in JavaScript. And in the next episode, or mainly in the next episode, we are going to actually write the code for a page that looks like this, with some static data. So we will see how we are going to write components, how we are going to compose them together, and maybe we will see how to use this input boxes to show the completed state of our to-dos. So we have 1 minute left, and I want to thank you guys for coming in and checking the stream. I hope you took something from this stream, and that you're going to take many other things from this whole series. So thank you guys for coming in, and make sure to stick out for to come and check in the next streams, so that we can finish our learning journey. Thank you guys all so much, and see you guys in the next episode. So thank you guys. Bye.